Hello and welcome to Algebra 2 Lesson 14. In this video, we're going to learn about solving absolute value inequalities. So in our last lesson, we learned how to solve an absolute value equation. So here we're just going to take the next step and learn how to solve an absolute value inequality. This isn't any more difficult, and the reasoning is the same. Okay, so the main thing I want to make sure that you understand, in case you didn't watch the last lesson, is the concept of absolute value. It's very, very basic, but if you don't understand it, you'll have a hard time understanding the structure of these problems. So the absolute value of a number is the distance between that number and 0 on the number line. So I have here a sample number line, and I just have two quick examples of absolute value. So we know that if we see a number inside of these vertical bars, that means we want to find the absolute value of it. So the absolute value of the number -2 is just 2. And so we know that from the number line, we can see that -2 is here and 0 is here. And so what I can do is I can count how far away -2 is from 0. It doesn't matter the direction I move, it's just how many units I'm going to move. So we would travel 1, 2 units to get from -2 to 0, so my absolute value is 2. And we all know at this point that if you take the absolute value of a positive number, it's just that number. If you take the absolute value of a negative number, you just make it positive. So here I took the absolute value of -2, just made it positive. So for the absolute value of 5, I just keep the number, right? It's just 5. And again, you can demonstrate this on the number line. Here's 5, and again, here's 0. And I would go 1, 2, 3, 4, 5 units to get to 0. And again, it doesn't matter which direction I go. We're just counting distance. It's just the same thing as if you get in your car and you ask your GPS how many miles you have to go to a certain location. Well, let's say, as this example goes, it's 50 miles. And let's say I'm in a different location now and it's exactly 50 miles away. It would still tell me I'm 50 miles away. It wouldn't say it's -50 miles now, or it wouldn't change based on the direction I'm coming from. 50 miles is 50 miles. Doesn't matter which way I'm coming from. So it's the same concept here. So absolute value can never be negative. It's a distance, so it's got to be 0 or positive. And I think about this with driving again. If I tell you we've got to drive somewhere today, we can either say, nah, I don't feel like going, and we drive 0 miles, or we can drive some positive amount. But we can't not go somewhere or drive backwards or something silly like that and come up with a negative distance. Okay, it just doesn't work that way. All right, so now that we understand the concept of absolute value, let's look at a very simple problem. All right, so let's take a look at our first sample problem. This is a very easy one that you'd see at the very beginning of the section. And it's just to understand what's going on when we're asking these questions. So the absolute value of x is greater than 2. What are we asking for? You might want to pause the video and just think about that for a second. What are we asking for? Well, we're asking for values whose absolute value is greater than 2. Or if I started at 0, what values are more than 2 units away from 0 on the number line? Well, if I just go 1, 2 in this direction, I know that anything larger than 2 would work. So I'd shade everything to the right here. And if I go 1, 2 units to the left, I know anything less than -2 would work. So I'd shade everything to the left here. So that gives me two solution sets, one where it's -infinity up to but not including -2. And it's the union of this with this other guy, anything larger than 2. So thinking about this, any number that's involved in either solution set here would satisfy this inequality. Just pick a number. Let's say we pick -8. Plug in a -8 there, take the absolute value, you get 8. 8 is larger than 2. Let's say you pick 3 over here. Take the absolute value of 3, you get 3. 3 is larger than 2. The only numbers that won't work are from -2 to 2, including both. If I plugged in a -2 there, the absolute value of -2 is 2. 2 is not greater than 2. That's false. So we know that this wouldn't work and this wouldn't work, and anything in between wouldn't work. If I chose 1, the absolute value of 1 is 1. 1 is not greater than 2. So for this type of problem, where we see a greater than, we're going to end up with whatever's inside the absolute value bars. So in this case, it's x. And it's going to be greater than 2. So in the first situation, you would just remove the absolute value bars, That's your scenario. X is greater than 2. Then you're going to have an OR. So it's going to be a compound inequality. And in the second situation, you're going to flip the direction of the inequality. So I would have X. I'm going to flip this. And I'm going to make this part right here, whatever's on the right side, negative. Now, you might say, where does this come from? Where? Okay? That's a common question you get in class, because this one right here, this is very straightforward. Everybody understands that X can be greater than 2. That makes sense. But for X to be less than negative 2, yeah, you can see it here. And once you kind of think about it, it makes sense. But once you get to the next example, it's like, where did that come from? Well, all you'd have to do is think about absolute value for a second. If X, and let me kind of scroll down a little bit. Remember, if I'm plugging something into the absolute value operation, I can think about negatives as well. So the negative of X could also be greater than 2. And if I divide both sides by -1 to get X by itself, what happens is I have to flip the direction of the inequality symbol. So this is going to become a less than, right, which is what I have there. And then this divided by this is just X, and then 2 over -1 is -2. So that's where it comes from. And once you see me do that, you can remember to do that on your own in the next example, and then you won't have to think about, well, what's the other scenario? This one's straightforward. This one everybody forgets, okay? So it's X is greater than 2 or X is less than -2. If you had a generic example like the absolute value of X is, let's say, greater than, I don't know, let's say some variable K. Well, this sets up to X is greater than K or X is less than -K. Just following this format here. In this case, K is just 2, right? So X is greater than 2 or X is less than -2. So here's another example, very similar. We have the absolute value of X is greater than 7. So again, what we're asking for here is, give me numbers whose absolute value or distance from 0 is larger or greater than 7. Well, I know anything larger than 7 would work. And also anything less than -7 would work. Because if I look at 0 here, if I count 1, 2, 3, 4, 5, 6, 7, yeah, anything to the left of -7, that works. And then again, 1, 2, 3, 4, 5, 6, 7. Yeah, anything to the right of 7, that works as well. That's a distance that's greater than 7 units from 0. But again, we don't need to pull out a number line every time. If I have a greater than, remember, use your generic example. The absolute value of X is greater than K sets up to X is greater than K or X is less than -K. So X could be greater than 7 or X could be less than -7. And again, let's do this one more time. Where does this come from? Well, I can take this part right here and say, well, the negative of X could also be greater than 7. The negative of X could also be greater than 7. I divide both sides by -1. This gets flipped. And so you'd have this cancels with this. X is less than -7. So that's where this came from. And again, you might be asked to write this in interval notation. And with OR, it's the union of the two solution sets. So I would have from -infinity up to but not including -7. And it's the union with the other solution set, which is greater than 7 out to infinity. All right, so now that we've dealt with the greater than scenario, let's talk about the less than scenario. So we have the absolute value of X is less than 3. So here, X can be any number that is less than 3 units away from 0. So anything less than 1, 2, 3 units. So it can't be 3, but it can be anything less than 3. So 1, 2, 3. Can't be -3, but it can be anything greater than that. So basically, it's the numbers that are between -3 and 3, shown here. And again, the first scenario to do this, where X is just simply less than 3, it's very straightforward. Just remove the absolute value bars, and you have X is less than 3. For the other one, you have to think about the negative of X is less than 3. Well, if I divide both sides by -1, what's going to happen is this gets flipped. This is now greater than. This cancels with this, and I'll have X is greater than -3. So this sets up a compound inequality with and And really, you could write this as a three-part inequality where x is in the middle. So x is going to be greater than -3, and it's less than 3. So it's between -3 and 3. And again, and just kind of erase this real quick. You could write something like this in interval notation pretty easily. You would put -3 next to a parenthesis, comma 3. So that's your solution set for this. Now, generically, if I had the absolute value of x is less than k, what I want is remove the absolute value bars. You'd have x is less than k. Then and you would also have remove the absolute value bars. You'd have x. Flip the direction of this. So you'd have greater than and make this negative. So -k. In each case, you basically do the same thing. But in one situation, you have or, which is when you have a greater than. And when you have a less than, you have an and. So let's take a look at the absolute value of x is less than 10. So following our last example, we know that x would be what? It would be greater than -10 and less than 10, right? See how fast I do that? So once you've got kind of the rules down, you can do these very quickly. But again, think about this as a concept. The absolute value of x is less than 10. So from 0, what's less than 10 units away? Well, I would go to -10, and I would put a parenthesis facing to the right, okay, because anything that is -10 or further to the left wouldn't work. Their absolute value or their distance from 0 is 10 units or larger. I'm looking for less than 10. So also going this direction, I would stop at 10. I'd put a parenthesis there facing to the left. Again, anything that's 10 or larger won't work because the distance from 0 is 10 or more, and we want 10 or less. So then we want all the values in between here. Again, x can be larger than -10 or less than 10. So in interval notation, I would just simply write a -10, comma 10 with a parenthesis next to each. And again, just to go through this one more time, we know that x could be less than 10. The other scenario is the negative of x could be less than 10. We divide both sides by -1. This flips, and we end up with x is greater than -10. So this sets up the compound inequality x is less than 10 and x is greater than -10, which we write as a three-part x is greater than -10 and x is less than 10. Okay, so that's where all this comes from. So now let's look at one that's a little bit more challenging. This is something you'll see at the very, very first part. So we have the absolute value of 2n minus 3 is greater than 13. So the first thing to make sure of is that the absolute value operation is isolated. So this is isolated. You have an inequality symbol and then some number. Now, the next thing you think about is it a greater than or is it a less than? Okay. In this case, it's a greater than. So with a greater than, we have or. All right. We set up a compound inequality with or. So the first one is remove the bars. So 2n minus 3 is greater than 13. Then or. The second one is remove the bars. So 2n minus 3. Flip the sign. So it's a less than. Make this negative. So negative 13. Again, the easy way to remember this, go back to your generic example. The absolute value of x is greater than k. So this turns into x is greater than k or x is less than negative k. Just use this as an example on the first few, and you'll remember. The first one is just remove the bars, as we have here. We just remove the bars. We have x is greater than k. The second one is remove the bars, flip the sign, make it negative. So we remove the bars. We flip the sign from greater than to less than. We made 13 negative 13. And again, where this comes from, if I took the negative of this, so let's say I had the negative of this whole expression, 2n minus 3 is greater than 13. What I can do is divide each side by -1, and I can cancel this. Divide this by -1, but this gets flipped. So you get 2n minus 3, which is this. Flip the sign. Okay, that's why we flip here. And then we make this negative. So this is negative 13. So again, that's where this is coming from. All right. So let's erase everything. Let's get our solution. So let's scroll down a little bit. So I just want to solve this like I normally would. So I'd add 3 to each side here. That will cancel. 2n is greater than 16. Divide both sides by 2, and I get n is greater than 8. Over here, I'll add 3 to each side. That'll cancel, and I'll have 2n is less than. Negative 13 plus 3 is negative 10. Divide each side by 2, and we'll get that n is less than negative 5. So I get n is greater than 8, or n is less than negative 5. So let's go back up and notate this. So your solution here would be, again, n is less than negative 5, or n is greater than 8. In interval notation, I could write from negative infinity up to but not including negative 5. And it's the union with this other set, which is anything larger than 8 out to infinity. Now, graphically, at negative 5, I'd put a parenthesis facing to the left, and I'd shade everything this way. And at 8, I'd put a parenthesis facing to the right, and I'd shade everything this way. All right, let's take a look at another one. So we have the absolute value of negative 10x minus 8 is greater than or equal to 12. So again, I'm looking at a situation with a greater than. Doesn't matter that it's a greater than or equal to. It's just going to change the notation a little bit. If I have a greater than involved, or greater than or equal to, it's a compound inequality with or. So I remove the absolute value bars. So negative 10x minus 8 is greater than or equal to 12. Then or, remove the absolute value bars, negative 10x minus 8. Flip the sign. So now this is a less than or equal to. Make this negative. So negative 12. And again, that comes from the fact that I can have the negative of this be greater than or equal to 12. I divide both sides by negative 1. This becomes negative, and the sign gets flipped. It's just that simple. So let's go ahead and solve each one here. So we'll have plus 8 and plus 8. That cancels. Negative 10x is greater than or equal to 12 plus 8 is 20. Divide both sides by negative 10. And this will cancel. I'll have x is less than or equal to. 20 divided by negative 10 is negative 2. So x is less than or equal to negative 2. And again, because I divided by a negative, I flipped the direction of that inequality symbol. Okay, for this side, I'm going to add 8 to each side to begin. That'll cancel. I'll have negative 10x is less than or equal to. Negative 12 plus 8 is negative 4. Let's go ahead and divide both sides by negative 10. Again, if I divide by a negative, I flip the direction of that inequality symbol. So this is going to be a greater than or equal to now. This cancels. X is greater than or equal to. Negative 4 over negative 10. I know that negatives would cancel. So this would be positive. Each is divisible by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So x is greater than or equal to 2/5 there. So this is an or. And let's erase everything and notate this properly. So we have x is less than or equal to negative 2, or x is greater than or equal to 2/5. In interval notation, again, it's the union of the two solution sets. So it's anything, we have negative infinity out here as the smallest, up to and including negative 2. So I'm going to use a bracket. And then the union with this guy. So including 2/5 and anything larger. So graphically, I can find negative 2 on the number line that's here. Put a bracket facing to the left and shade everything going this way. Now 2/5 doesn't have a notch, but 2/5 is 0.4 as a decimal. So it's a little bit less than a half. So let's just say it's like right there. Let's say this is 2/5. And again, it's anything that includes 2/5. So that value or larger. And again, if you have this on a test, your teacher's going to allow you to make notches where there are, right? They understand that. So it's not perfectly at 2/5, but you've notated where it is. That's the best you're going to be able to do. So again, anything that is less than or equal to negative 2, along with anything that is 2/5 or greater, would be a solution for this inequality. All right, let's take a look at another one. So we have 8 times the absolute value of negative 8x plus 2 minus 2 is greater than 110. So common mistake is, after you've seen these easy problems, you go through and you start saying, okay, well, 8 times, remove the bars, negative 8x plus 2 minus 2 is greater than 110. Or then you take this and you say, well, 8 times and then inside of parentheses, negative 8x plus 2 minus 2 is less than negative 110. No, okay? Do not do this. Wrong. You have to isolate the absolute value operation first. You want it to look like this. The absolute value of something, let's just say x, doesn't matter what it is greater than some value k. So this x could be anything. It could be the absolute value of ax plus b, if you wanted to make it more complicated, is greater than k. This leads to what? X is greater than k, or x is less than negative k. This, the more complicated example, just leads to ax plus b is greater than k, or ax plus b is less than negative k. Okay? So the main thing here is to isolate the absolute value operation first, and then just follow this formula here. Write it on a flashcard and keep using it. All right, let me erase this real fast. And let's go ahead and simplify. So I'm going to add 2 to each side. I'll have 8 times the absolute value of negative 8x plus 2. This is greater than 110 plus 2 is 112. Now, I want this by itself. I have multiplication here, so I'm going to use division to get it by itself. Divide both sides by 8, and so this will cancel with this. You scroll down, get some room going, and I'll be left with the absolute value of negative 8x plus 2 is greater than, what's 112 divided by 8? Well, most of us don't know that off the top of our heads, but punch it up on a calculator and you'll get 14. Now, I have something that is matching, again, what I saw earlier. The absolute value of something, let's just say x, is greater than k. So, the absolute value of negative 8x plus 2 is greater than 14. Remember, this sets up as or. So, x is greater than k, or x is less than negative k. Same thing. This is or. So, we have negative 8x plus 2 is greater than 14. All I did was just remove the absolute value bars. Then or. Remove the absolute value bars, so negative 8x plus 2. Flip this direction here, so this is a less than. Make this negative, negative 14. So you're basically good to go at this point. You just need to find your solution for this. So we're going to subtract 2 away from each side, and that'll cancel. I'll have negative 8x is greater than 12. Divide both sides by negative 8. You're going to flip the direction of this guy. This will be a less than. This cancels with this. I'll have x is less than 12 over negative 8. Each is divisible by 2. In fact, each is divisible by 4. So if I divide this by 4, I get 3. If I divide this by 4, I get negative 2. So let's put negative 3 halves. And then let's look at the other guy. So if I subtract 2 away from each side over here, this is going to cancel. I will have negative 8x is less than. Negative 14 minus 2 is negative 16. Divide both sides by negative 8. So this will cancel with this. And what I'll have is x, and I've got to flip this, is greater than negative 16 over negative 8 is 2. So x is less than negative 3 halves, or x is greater than 2. So again, we found that x was less than negative 3 halves, or x was greater than 2. So in interval notation, it's the union of the two solution sets. So coming from negative infinity up to but not including negative 3 halves, and the union with this other guy after 2, right, anything larger, out to infinity. Graphically, I don't have a negative 3 halves, but negative 3 halves is negative 1.5. So it's between negative 1 and negative 2. So let's just say it's right there. This is negative 3 halves. It would be anything less than that. So I would put a parenthesis facing left, shade everything to the left, and then anything larger than 2. So put a parenthesis at 2, and we'll shade everything to the right. So again, x can take on any value that is less than negative 3 halves, or it can also take on any value that is larger than 2. All right, let's take a look at one now where we have a less than. So we have the absolute value of negative 6 minus 4n is less than 6. So again, if we see something in this format, the absolute value of x is less than k, it's a compound inequality with and. So x is less than k, but it's also greater than the negative of k. Okay, so you have x is less than k, and x is greater than the negative of k. So I'm going to take this part right here, and I'm going to say negative 6 minus 4n is less than 6. So the same as it looks right here, just drop the absolute value bars. Then and, okay, now you have and because you have a less than. It's also true that negative 6 minus 4n is greater than, flip the sign just like you do before, make this negative, so negative 6. So negative 6 minus 4n is greater than negative 6. So we can write this as a three-part inequality, make it easy on ourselves. So we have negative 6 minus 4n in the middle. It's greater than negative 6, and it's less than positive 6. So I can just erase this, and I can drag this up here. And again, if you're wondering where this came from, I've showed it multiple times, but it's basically that we take the negative of this, so negative of negative 6 minus 4n. This is less than 6. Because of the absolute value operation, that would work as well. And then we divide both sides by negative 1. So this cancels. That makes me flip the sign, and then this becomes negative 6. So we have this guy right here, negative 6 minus 4n. The sign is flipped, and then we have negative 6. So that's where this part right here comes in. Let me erase all this now, and let's just attack the problem. So if I solve this three-part inequality, I do the same thing to each part. I'll add 6 over here and over here. So that'll cancel, become 0. That'll cancel. I'll have negative 4n is less than 6 plus 6 is 12. So I divide each part by negative 4, so I can isolate n. And what's going to happen is, again, I've got to still flip the direction when I have a three-part inequality and I divide by a negative. That doesn't change. So this gets flipped, and this gets flipped. So this is greater than, this is greater than, this cancels with this, and I'll have n. So n is less than, 0 divided by negative 4 is 0, and it's greater than, 12 divided by negative 4 is negative 3. So generally we don't leave it in this manner. We rearrange it to where it's in the direction of the number line. So negative 3 would be here. Of course, that's less than n, and we know that n is less than 0. So let's take this solution up, and we're going to graph it and use it to write an interval. So n is greater than negative 3 and less than 0. So here's negative 3. So it's greater than that, and it's less than 0. So it's between negative 3 and 0. So that's what it looks like graphically. And in interval notation, I just have the interval greater than negative 3, but less than 0, just like that. So n, again, can take on any value that's greater than 3, but less than 0. All right, for the next one, we're looking at 7 times the absolute value of 10k plus 3 plus 7 is less than 28. So again, I want to isolate the absolute value operation before I do anything. Don't make the mistake of just trying to apply the rule before you have isolated the absolute value operation. So I want to subtract 7 away from each side first. I'll have 7 times the absolute value of 10k plus 3. This is less than 28 minus 7 is 21. So now I can divide both sides by 7. And when I do that, this will cancel with this. I've isolated my absolute value operation. It's the absolute value of 10k plus 3. And this is going to be less than 21 divided by 7 is 3. So now I can go ahead and apply my little formula. Remove the absolute value bars. So I'll have 10k plus 3, and then it's just less than 3. And the other scenario would be that 10k plus 3, remove the absolute value bars, flip the direction of the inequality symbol so it's greater than, and then make 3 negative, so negative 3. And again, to make this easy on yourself, write it as a three-part inequality. So go ahead and write this as 10k plus 3 is greater than negative 3 and less than 3. So let's subtract 3 from each side. So this will cancel. Negative 3 minus 3 is negative 6. This is less than. We'll just have 10k now. And it's less than 3 minus 3 is 0. Divide each side by 10. This will cancel with this. And I'll have k in the middle by itself, which is what I want. And it's going to be greater than negative 6 over 10. I know it's negative. 6 is divisible by 2. 6 divided by 2 is 3. 10 divided by 2 is 5, so negative 3/5. And 0 divided by 10 is, of course, 0, so then less than 0. So k is greater than negative 3/5 and less than 0. So in interval notation, that's not including negative 3/5. up to but not including 0. So it looks like that. And then on a number line, where is negative 3/5? Well, it's negative 0.6. So if you look between 0 and negative 1, it'd be a little bit past negative 0.5. So let's say about right there. We could say this is negative 3/5. So here's 0. So what I would do is I would put a parenthesis here facing to the right, one here facing to the left. It's kind of a small area on our number line. We'd shade everything in between. So again, k can be anything that is greater than negative 3/5 up to and not including 0. So anything in that range between, again, negative 3/5 and 0. For the last problem we're going to look at, we have 5 times the absolute value of negative 3 plus 8x plus 2 is less than or equal to negative 53. So again, I want to isolate the absolute value operation first. Don't just start applying rules to stuff. That's a common mistake. So let me subtract 2 away from each side of the inequality. That'll cancel. I'll have 5 times the absolute value of negative 3 plus 8x, and this is less than or equal to negative 53 minus 2 is negative 55. So now let me divide both sides of the inequality by 5. So again, I can isolate this part right here. This will cancel with this, and I'll have the absolute value of negative 3 plus 8x is less than or equal to negative 55 over 5 is negative 11. Now, am I going to continue with this? No, I am not. Why? Think about this. The absolute value operation produces a result that is 0 or it is positive. It cannot ever be less than or equal to negative 11. That's not going to work. It can't be less than a negative value. It has to be greater than or equal to 0. So this has no solution. This has no solution. And again, when you see something with no solution, you can say the solution set has no elements, so you put the symbol for the null or empty set. One more time, if I try to plug in something for x, multiply by 8, and add negative 3, when I take the absolute value of it, the absolute value will never be less than or equal to negative 11. It won't ever happen because the absolute value is either 0 or it's positive. So that's why, again, there's no solution.